Hello there, Algebras, and welcome to your Chapter 14 Lesson 2 notes on creating scatter plots. So a scatter plot is going to be a plot of points that make up two separate variables that we are trying to compare. Those two separate variables of data are the bivariate data that we are analyzing. So we want to see if there is any sort of relationship between these two specific data points that we will have gathered together. And so what happens is the independent variable, whatever time has passed, whatever that particular piece might be for us, is going to go on the x-axis. That's going to be our x coordinate. Our dependent variable is going to be on the y-axis. That's going to, the thing that we think depends on the other piece occurring, we think is going to go on the y-axis. So when you're given your sets of data, you will be given two full sets of data. For example, in this example that we're about to plot to create our scatter plot, we are given that we want study hours compared to Regents exam scores. So we think that the study hours are going to be the independent variable. And we think that the score you get on the Regents exam is the dependent variable. How much did you study should have affected your score on the test. Okay, so that's what we think is going on in this case. Now, what we are going to do is plot these points, and I am going to show you how to then make a scatter plot on your graphing calculator to also help us get a little forward in analyzing the data. Okay, so first things first, with our scatter plot, we need the data. Now notice that this table of data already put our study hours into our X column and our Regents score into our Y column. So this already did that for us. What we're going to do is look down all the study hours and then look at our graph that we've been given and scale our X side of our graph. So our X axis of our graph, we'll scale it based on what is the maximum that we need to fit on the X axis. And then we'll do the same for the Y, and we'll figure out a scale so that we can get from the minimum to the maximum fitting on our Y axis. Okay, so one axis at a time doing this. I'm just making sure my paper stays down. Okay. All right, so study hours, study hours, study hours, study hours, study hour. Okay, we got some X's, 7, 7, 7. So if we look down on our x-axis, we clearly have enough space to kind of space this out a little bit. We don't have to squeeze them all in. So we're always starting with 0. And then let's kind of skip count. 1, and then skip 1, 2, skip 1, 3, skip 1, 4. And there's where 5 is. 6, 7 is our max, actually. But we could get all the way up to 10 if we follow it this way. So now I am labeling each tick that we made on the x-axis. And then what I'm also going to do is I'm going to label that the x-axis is study time, and then in parentheses, in hours. So we know what was the way that we measured how much study time we had. Now what I need to do is look down the Regents scores. Okay, so it does look like our max score is 100. It looks like our minimum score was this 50. Oh, oof, I passed that 40 right there. Looks like our minimum score was this 40. Okay, so Y's, we need to really count up and see what we've got going on there because we knew we had plenty of space over here to fit our 7 hours as our max. It does look like we're going to have to figure out our scale for our Y's. So, of course, this line is your 0 for your Y's. So that's a 0 on the Regents exam, which we don't have in our set of data, but that would be if we had that 0, that's where we need to be starting from because we know that that's the lowest score you can have. Up to our maximum score of 100, which someone got. Okay, so let's count how many ticks we have here. 1, 2, 3, 4, 5. Oh, look at that. This bold line is every 5. So 5, 10, 15, 20, 25, 30. So let's take 100 in our graphing calculator and divide it by 30 and see what we get. So we couldn't go by 3s, but we could go by 4s. Based on the data, probably smarter to go by 5s, right? Because all of these data end in 0 or 5. So let's go by 5s. 5, 10, 15, 20, 25 would be this golden line. And we're not going to need anything below 25 anyway, but it's a good measure of where we're going. 30, 35, 40, we know we're going to need a 40. 45, 50, we know we're going to need a 50. 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. So in the space where I knew I needed each of those values, I wrote down every single value. And of course, what I'm going to write on this side is that this is Regents score. Now what I'm going to do is actually plot my points as each of these. So the X, comma, Y creates the X, comma, Y coordinate point that I graph. So 380, plot a point. 590, okay, 5, comma, 90. So that's telling me 5 hours of studying, 90 on the Regents. 5, 90, plot a point. Notice what I'm doing is kind of going through and making sure I check off that I have plotted that point. I did start by making them actual coordinates here, but I have a feeling now you see that pattern. So 275 and plot your point. 680, 680, okay. 790, 150. 1 hour of studying, 15 on the test. 2 hours, 65. So 2 hours, 65. 7 hours, 85. Sorry, my calculator is getting in my way. There we go. 1 hour, 40. And 7 hours, 100. Okay. Do not connect these points. Each of these points represents specific data gathering for both of the variables that we are testing. Now, the question is, does it look like there's a relationship between the number of hours studied and the Regents score received? Let's think about it this way. Does it look like we could draw a line here and approximately the same number of points are above or below that line? And it does look like they're kind of linear and a few above and a few below. This is a relationship. So this is showing some sort of relationship, or what we would call correlation, between the amount of time studied in hours and the Regents score received on the exam. Okay, so the last thing I want to do is title my graph Hours Studied versus Regents score, which they gave us. And there we have it. That is how we create a scatter plot. Now, this line that I just kind of sketched in as a general, like, oh, it looks like there might be a bit of a relationship. That's what we're going to study tomorrow. That line has a name, and there's a reason that I kind of like drew it in to show you there's definitely a linear relationship going on here, okay? So we do believe that there is a, oops, I spelled it wrong, 2 R's, correlation, okay? A relationship between the data points. We believe that that exists. We'll study tomorrow how to get that relationship. But today I do want to also show you how to plot these points in your graphing calculator. So this is a pretty cool thing that our graphing calculators can do for us. We can actually put these points into certain spots and then use those to run an actual scatter plot on our graphing calculator screen so that we can see it. So, okay, let's grab our graphing calculator and we are going to press Step and Enter so that we see a highlight in what's called L1. That is list 1. List 1 is where I am going to put the data for my X variable. In this particular case, it's the hours studied. So what I'm going to do, just like I did in univariate data, is I'm going to start entering this data 3, then enter, 5, then enter, 2, then enter. So straight on down the line, we are entering all of the X values exactly as is. And what we notice is we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 X values that we have entered into L1. It is asking me for the 11th data value, which I don't have. I only had 10 data values. And now the cool part is I can arrow right into L2. And in L2, I can put each matching Y value. So it will look just like my table on my paper. And straight across will be each of my different coordinate points. So now it's going to be 8, 0, enter. So this coordinate point straight across is 380, just like it was on my table on my paper. So now the next one is 590. Okay, so 90 is my next point. 75. Okay, so notice it's matching up with 2. So notice as I'm going, I'm making sure that the coordinate points that I have already graphed are actually matching up as X value, then Y value. So I'm making sure of that as I plug in my Y values down my table for for L2. So I'm making sure that these points are lining up. You have to have the same number of data points in L1 as in L2 in order to run the pieces that we will run tomorrow, and in order to plot a scatter plot. So notice everything's lined up. I've got all my X values in L1. I've got all my Y values in L2. If you need more time to enter your data into either of those two lists, please pause this and take that time. Otherwise, it's time to actually run our scatter plot. So now, if you notice this blue stat plot up here, right above y equals, that's where we're going to go. Press second, because it's blue, and y equals, and we're going to turn this plot on. So press enter, then enter again. We have just turned plot 1 on. Now, the beauty of running a scatter plot on your graphing calculator is once you turn plot 1 on, it defaults to a scatter plot, arrow down to be highlighted on the scatter plot. So you see the little plot that has all the dots on it. That's a scatter plot. And it also defaults to your X list data in L1 and your Y list data in L2. So actually, once you turn your plot on, if you have just cleared your RAM, you're going to get a scatter plot out of this. Now, if you just pressed graph right now, your graph is still going to show up as a 10 by 10 grid, and you may not see this data. But there is a special place we can go to make this visualize our data for us. And that would be pressing zoom, and then notice number 9 is stat. So either arrow down to 9 and press enter, or press 9 right now, and it goes straight to your graph and shows you your scatter plot. And this scatter plot that we are seeing on here, it is scaled differently from ours, and mostly because look at this particular size of your screen. The size of your screen is different from the size of my graph right here. But we can see an extremely similar pattern. And we can definitely see that linear-like pattern that is occurring here between the study time in hours and the Regents score we receive. So we can actually visually see that in our graphing calculator as well. Tomorrow, when we take this one step further and talk further about correlations and what that means to be this linear relationship that is occurring between your data values, tomorrow when we do that, I will show you how to do specific things in your graphing calculator that help us make some decisions about, is this a good fit? Is this nice linear? What is that line that I was talking about that kind of describes the data a couple above, a couple below? But that's what we'll be doing tomorrow. So for now, let's try one more of these to make sure we have our scatter plot down pat. Very similar theme we have running as far as our data goes. We're this time looking at our study time versus our GPA. An apt theme. The study time we can see is our X and the GPA is our Y. So when we go to enter our data, the X's will put in L1 and the Y's will put in L2. Okay, but for now, what we're going to do is get these plots onto this graph. So first we're going to graph this data. Now, if we look at this, okay, we can see this is exactly the same graph we had on the front, which means we know that the y-axis is up to 30. We know that the x-axis is going to 20. So since this time my study time gets me all the way to 20 as a value, I am going to mark every tick on the x side of my axis with a number. And just for the sake of both time and space, I'm going to label the evens. Okay, so we know each of these is a study time, but I am labeling up the even hours of studying. Again, time and space. Trying to be efficient with both of those. And when you've got that part done, we write study time, and I'm going to write hours per week. That's how we're measuring that study time. Now, the y side is going up to 100 again. This time, of course, we know that 100 divided by 30, because we know we got 30 ticks up. We know that that's 3.3, so we can't go by threes. Last time I went by fives because all of my data ended in a 0 or a 5. But this time, notice all of my data does not end in a 0 or a 5. So it's actually wiser to go by fours because we'll spread out the graph a little bit more. So 0 is, of course, my very bottom. So 0 hours of studying per week. 4, 8, 12, 16, 20. Oh, sorry, I said hours of studying. That's our GPA. We don't have any of the values of our GPA in below 20. So I just ticked off those. We also don't have any of those below 40. So when you do 24, 28, 32, 36, 40, you really don't have to label any of those individual spots. We do have a few that are below 60. So this time I'll go 44, 48, 52, 56, and 60. Oh, 61, I guess, is my lowest. Oh, sorry, 64, I guess, is my lowest. So 64, 68, 72, 76, and 80. So we do know that our data will really fall up here, but at least we know that we've got a nice even scale going. 84, 88, 92, 96, and 100 is our max GPA. So this is GPA, which stands for grade point average. I'm just going to label the top while I am here, study time versus GPA, grade point average, and we'll go from there. So now let's get each of these individual points on here. 264, so 2 hours, and 64 is a grid point. 4, 71. So 71 is not an even number, so it won't be a grid point. So 4, we know 72 is here, so we're a little closer to 72 than we are to 68. 5, 69. So 5. And we got 68 right here, so just above it. Closer to 68 than 72. 7, 74. Halfway between 72 and 76. 10, 81. So we've got an 80, so just above it is an 81, closer to 80, of course, than 84. 12, 86. Okay, so that's going to be halfway between 84 and 88. 14, 84. That'll be right on a grid point. It's been a minute. 17, 94. Okay, that'll be halfway between 92 and 96. 1991. Okay, 92 is this line, so just below 92. And 2096, that'll be on this grid point right here. No 100 GPA. Does it look like there is a relationship between study time and GPA? Yes, and it does look like it's forming a loose line. This line does look a little more closely compact than our last line, which would indicate to me that most likely when we run our diagnostics on this tomorrow, we will probably see a very good relationship or correlation, which is one of the things we will study. We will probably see a very good correlation or relationship between these two data values in this study. One more time, I want to show you how to enter this data into your graphing calculator. So press Stat and then Enter. We have the last set of data still in here. So what you do to clear out that data is arrow up so that L2 is highlighted and press Clear, then Enter, and the whole list clears. So then arrow to the right, arrow up so L1 is highlighted, and press Clear, then Enter, and then that clears out L1. Now L1 is where we want to put our study times. So I'll go across that first column and start entering 2, then 4, 5, 7, and we'll continue. We're entering our X values, which is our study time in hours per week in our L1. So again, there are 10 pieces of data, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for each of my two variables. So I am being asked for the 11th piece of data. However, I don't have any. So now what I'll do is arrow to the right so that I'm in L2, and I will start entering my Y values, my GPAs, and I will make sure as I'm entering them that they line up with the study times that I already entered in my Y list. Notice I made a mistake, so it should be 1286, and then 1484, and 1794. And now it's 19 and 91, and 20 and 96. So there you go. I just arrowed up when I made my mistake and wrote right over it. Okay, so now if you press second and y equals to go into a stat plot, you actually already have plot 1 on, but you're going to want to press zoom and 9 to redo that graph for this particular data. So again, just let me show you. In second and y equals and enter, press enter again to turn on this plot if it were not already on. Notice it defaults to a scatter plot with the X list in L1 and the Y list in L2. So you can then press zoom 9 to see this data. And it does look better than last section's data. It really does. The last example's data was a little bit looser fitting. This data does look better. What we'll do with that tomorrow is we will actually study. There are ways to figure out why this data is better mathematically than why the other data is not quite as good, but it's still got a relationship occurring. And we will start to look at what values I use to determine that. First, we need to make sure we are practicing our scatter plots. So please make sure you are trying the 14-2 homework where you're creating your own scatter plot. And after we do that, tomorrow we will use what we know about entering this data into the graphing calculator to then take it one step further and know some actual numeric reasons why this study time GPA relationship was actually a better relationship than the hours studied and the Regents score. But we'll wait until then to figure that out. Okay, my fine friends, enjoy your 14-2 homework, and I will see you tomorrow to run ourselves some linear regression. Have fun with the scatter plots. Bye.